So often in designing external loads, alright, the only thing that we actually concern is actually to drive a motor, because a motor itself requires a larger current, alright, than the Arduino can supply. So therefore, let's talk about the DC motor. Alright, is that the DC motor is designed in a way that your motor can only run in one direction. Alright, so your motor can actually spin in only one direction. So how can we have the DC motor to go in different directions, both directions? Alright, so the motor can spin in this manner, or it can spin in this manner. Alright, if it's spin in this manner, this means that it's from plus to minus, I think. If it's spinning in this manner, it's from plus to minus over here. Alright, so something that for you to know lah. Alright, nonetheless I may be wrong, but anyway, so in order to do that, we require 4 switches. Alright, so these 4 switches, this over here, this is 2 designs. So you have a plus and you have a minus over here. So if you want to turn in this direction, you connect a plus over here, so this plus will actually go to the minus, you see, so you will turn in this manner. Alright, nonetheless, if you were to go from plus to minus, which is the ground, then over here this will turn in this manner. So it's a bit component intensive because you need many switches. Alright, so therefore over here they use a 4 mosfet. Alright, they actually uses 4 mosfet system to actually help out. So this logo over here is a MOSFET, alright, which is the same logo as this one. Okay, so you need to identify the MOSFET, and this one is the diode. Alright, this is the standard NPN PNP system, but this is in terms of two diodes. Alright, so you need to understand and utilize how these symbols work around with you. Okay, so these are the things that you may need to understand. Alright, so just take note of that the green color or the arrows over here denotes the power supply. Over here this denotes the power supply. Alright, so coming from a amplified one. Alright, so if you have a positive one, it flows through here. Alright, it opens the gate will allow a larger supply of power to actually flow in. Alright, and you'll turn the motor in this manner. Okay, this is how it works lah. Okay, likewise for this one, this is actually talking about a few understandings about the PNP and NPN, where we talk about the switches. Alright, yes, I think at least you get what I mean. Okay, so therefore yeah lor, must take note that this method of connecting is called the H bridge. Okay, and that the gates for your MOSFET, alright, must be driven correctly, alright, to give a desired connection. So please do that and not short the power supply. Alright, so therefore you require a special controller IC to actually provide modes for braking and sleep. Alright, so sometimes this is off, sometimes this is off, and this is running in this manner. And then in sometimes this is off, sometimes this is off, and this one is on, this one is on. Alright, this thing is on now, this thing is on now, then you'll provide this direction, things like that. Alright, so these are little stuff lah. At least you get a feel of things. Alright, so I think this is it for the motor part, because I think in the later part we don't need anything about. We still talk about motor, but we talk about other stuff, talking about the speed of the motor. How can we vary the speed of the motor? Because what we do for the NPN, PNP, or even the MOSFET itself is allowing full state, meaning full state on or full state off. Alright, you don't have something in between. Alright, as you can see, once you open the gate, everything flows in. Alright, either for your MOSFET or for your PNP or NPN. Alright, once you open the gate, all the power supply will actually flow in full state. So how can we actually control the variations of the power? Alright, and therefore this is what we're going to talk about in the later parts. Alright, and therefore shall see you there.